Hi, welcome to Calculating Angle Between Vectors, a video from the Vectors topic at Higher Maths. What we're going to do today is use the scalar product that we already worked with in the last couple of videos and magnitudes that we know already to calculate the angle between two vectors. Now, on your formula sheet is this. A dot B is equal to the magnitude of A times the magnitude of B times cos of theta. What we're going to look at today is being able to find the angle between two vectors. So what we're going to do is we're going to rearrange that. We're going to rearrange it because really what we want to calculate here is theta. Okay, so if we rearrange, not for theta, but for cos theta, because that's a bit neater, we need to divide by the two magnitudes. So cos theta is going to be the dot product divided by the magnitudes of A multiplied by the magnitude of B. Okay, and we know dot product from the last video here. We need the angle to calculate a dot product, so we're going to have to use the other one in order to calculate the angle. So when we multiply all the components together and add them. Okay, and then the magnitude is obviously when you square root there. So this is how we are going to find angles between two vectors. And again, we need to be careful that the vectors are both pointing away from the angle. Okay, I'd maybe copy that into your notes under the heading from the video, angles between vectors. Okay, and we'll look at a couple of examples. Okay, so I want to calculate the angle between vectors P and Q. I'll give in the basis vectors there. So I know that somewhere down here I'm going to be using the dot product divided by the magnitudes. Okay, now I need to calculate these. So let's do the dot product first. A dot B is what happens when we multiply these components together. So it's going to be 2 multiplied by 4 for your i's, add 5 multiplied by 2 for your j's, and then add 7 times 2 for your k's. So that's 8, add 10, add 14, so 32 is your dot product there. Next, we need the magnitude of A, which we know is the square root of 2 squared plus 5 squared plus 7 squared, which is 49, 53, 78, root 78. Okay, and then the same for magnitude of B. Okay, so the square root of 4 squared plus 2 squared plus 2 squared, which is root 24. Okay, so that's us done all our kind of legwork for it. Now, if we're looking for cos of theta, the dot product is 32 over root 78, which is your magnitude of 8, multiplied by root 24. Okay, so cos theta, can I reset to calculate this? Okay, so that cos theta is 0.739, that's a point there, 7396 and so on, which means theta is inverse cos of your answer there, which will give you 42.3 degrees for your angle between the two vectors. Okay, so it's rearranging a formula we already know and already have worked with, and then doing the legwork behind that. Now, the next thing I'm going to show you is a past paper style question. These are very popular in the past paper, and this one here has come from HSN, which is a brilliant website I'm going to presume you've been on, and if you haven't, then you definitely should have that as a bookmark. Very kind of typical one. Use some coordinates, then find some vectors, and then calculate the size of the angle. Okay, so the diagram shows a cube. The point R is 400. I'd maybe say give this a wee shot yourself. Give it a pause and try this question yourself. I'll go over it. I'll still be here going over it once you come back after pausing it. Okay, so that means t is 0 in the x-axis, 4 in the y-axis, and 4 in the z-axis. So t is 0, 4, 4. And u, that's up here, so it's 4 along, 4 back, 4 up. U is 4, 4, 4. Okay, part B is looking at the components of RT and RU. So RT, we know is T minus R. The position vector T is going to be very similar to the coordinate. It's going to be 0, 4, 4. Subtract R, which is 4, 0, 0. So RT is going to be negative 4, 4, 4. And then we'll do something very similar for RU. U subtract R, well that's 4, 4, 4. Subtract R, which is 4, 0, 0. So that's going to be 0, 4, 4. Okay, now we'll look at part C and I'll do part C on the other on another page, but calculate the size of angle TRU. So we're looking for the angle there that goes from T to R to U. Now if we want that angle, we need to have both vectors pointing away, which means we need vectors RT and RU. But luckily, look, we've got them already there. Okay, so we're calculating the size of angle TRU. Okay, we know that cos theta is going to be RT dot RU over the magnitude of RT times the magnitude of RU. Okay, and this is where I just noticed I've maybe done an imperfection in the last one. Here, I shouldn't have used A's and B's because I'm not using vectors A and B's, I should use P's and Q's. Okay, so notice in this one here, I've used RT and RU because that's the vector I'm using. Okay, so that's the legwork I need to do. So I'll do it over here. RT dot RU means -4 multiplied by 0, add 4 times 4, add 4 times 4. That's 0, add 16, add 16, so that's 32. The magnitude of RT is going to be the square root of -4 squared, add 4 squared, add 4 squared, which is root 48. And then RU is going to be root of 0 squared, add 4 squared, add 4 squared. 16 add 16 is root 32. So cos theta is equal to 32 over root 48. Root 32, give me a wee second, I'll calculate that. Okay, and that gives you 0.81649 and so on. So which means theta is inverse cos of that answer, which gives you 35.3 degrees. Okay, so it's rearranging your cos theta. Again, sorry about that, but be careful you're using that as with the vectors you're actually using the SQ. Want to see that, so you should be doing that because it's best practice, and then it's just doing the legwork behind that. Okay, any issues, ask your teacher and you'll do more practice in class by yourself. Cheers.